Alright guys, so what we are going to be doing now is figuring out how far apart these 2 points are. And we were pretty successful in doing that up here where we were drawing our lines and we were determining how many spaces I had gone in Y, or up and down, and in X, which is left and right. So now what I need to do is figure out how I can do this when I'm not given a graph, because I'm not sure about you, but I wouldn't really feel comfortable doing a bunch of work on a hand-drawn graph. I don't think that's going to work out really well for me. So what I'm going to do is I'm actually going to set up a quick formula. And how that formula is going to work is this. I'm going to look at only my y's right now. And I know that in the alphabet, X comes before Y, so we're going to say our Y's come second in both of our coordinates. And again, just to reiterate, X, Y, Z, we don't have Z's right now, so we know Y comes second because it comes second in the alphabet. So I'm going to take my Y's, and as my instructions over here tell me, determine the change in Y. So what's the change in Y? Well, let's do, I don't know, let's go this way. We could do the other way too, but let's take it backwards. So I have -6. And I know that change can be represented by a substitution. It'd be like me saying, oh, well, what is the change if I go from where I am now all the way back to school, or all the way back home? What would my change in my distance be? So I'm going to do this by doing subtraction. So I'm going to say -6 minus 4. Now the reason I did that is I wanted to find out how far away these two are, how far apart they are. And if I added these, I wouldn't get that. I would get pretty much where the halfway point is. I don't want that. I want how far apart they are. So I say -6 minus 4. -6 minus 4 is -10. Because if I owe you $6 and I borrow 4 more, I owe you $10. Now, step 1, it says determine the change in Y. I did that, substitute this for A. Well, let's come over here and do what I do every single time, as I've stressed a million times. A squared plus B squared equals C squared. Well, I need to substitute this for A, so I say -10 squared plus, well, what's my next step? Determine the change in X. Well, my change in X, well, we'll make it green, why not? The change in X is going to be, well, if I went that way for the first one, I have to go that way for the second one as well. Main rule here is you just have to go the same direction both times. You could do it going this way, but force of habit for me, I don't do it that way, I do it this way. All you have to make sure you're doing is taking it the same direction of subtraction, like we see up here, these arrows, the same direction of subtraction each time. So I'm going to say -5 minus -2 equals, well, minus a negative is really plus a positive. So -5 plus 2, if I owe you $5 and give you 2, I owe you $3. So I'm going to say -10 squared plus -3 squared equals, and this is going to allow us to determine C squared. So let's actually go in and solve this. -10 squared, hopefully you've seen, is 100. It is not -100, but a negative times a negative is a positive. And therefore the same logic holds true, plus same logic holds true for this -3. -3 times -3, or -3 squared, is 9. And all of that equals c squared. So as I go in, I'm going to calculate the addition here, which is going to give me 109. Let me switch back to an easy to see color. 109 equals c squared. And I know my last step is I always square root this, so I find out, well, the square root of 109 is best represented by, well, the square root of 109. So this is the most precise answer we could give. But let's say the instructions up here didn't say that. Let's say the instructions up here said how far apart are the points -2, 4, and -5, -6, round to the nearest tenth. Well, then I have to do some estimation. And doing a quick callback to what we've done before, that means I'm going to say, well, 109 is between the square root of 100 and the square root of 121, which is 10 and 11. And this appears to be essentially halfway between the two of these, just slightly closer to the square root of 100, but I'm still going to estimate around 10.5 as an estimate for the length of this line. So again, the idea here is this is technically the most correct answer. I know that seems weird that we can have a square root as an answer. Units. And if we wanted to estimate, we could also do that.